Hello everyone, my name is Asad Iqbal and welcome to my YouTube channel. So guys, in a previous video we had a look at how we can use YOLOv9 pre-trained model to make the inferences on an image without any training. So the goal of our today video is to fine-tune the YOLOv9 model for our custom dataset, right? And make inferences on a test data. We will also make the inferences on a video as well. So first of all, we need a dataset to fine tune the model, and we will use construction site safety dataset, which is freely available on Kaggle in a YOLO V8 format. The format for the data for YOLO V8 and YOLO V9 will be the same. So that's why we are using the same dataset from the Kaggle. So in order to download the dataset from the Kaggle, we need to have an Kaggle token API, and you can easily access it from your Kaggle account settings. And after downloading the Kaggle API, you can import it into your Google Colab environment. And this token will be downloaded in a kaggle.json file. You have to import this kaggle.json into your Google Colab environment, right? So let's get started with our project. So let's install the Kaggle Python API using pip. By using this, we can directly download the dataset from the Kaggle into our Colab environment. So before running the cells, make sure you have to connect with the GPU. We can change the runtime to the GPU, okay, and save it. So after connecting with the GPU, let's first install the Kaggle API. So we can easily download it and install it using pip. So after installing the Kaggle, and now we have to make a one directory called .kaggle, which will save all the Kaggle configurations and file. And let's run it. Now we need to import the downloaded Kaggle token API from our Google Kaggle account into the Colab environment. So let's import it. We can it will be in a kaggle.json file, okay, and now copy this kaggle.json file into this folder that we have just created right there, right? So let's run the cell. After running the cell, so now we are setting the permission for our Kaggle API using this chmod command, which is stand for the change mode, right? So let's run the cell. After running the cell, now let's download the dataset from the Kaggle, and we can just copy the API path of the dataset, and I will be mentioning the link of this dataset in the video description. You can access it easily from there. Just run the cell. As you can see, our dataset is downloaded and it is in a zip file. So we need to extract the data from this zip file. So for that we are using unzip function, which will extract all the content that is present in a zip folder. I just copy this path and paste right there, right? Okay, now let's run this cell. Once execution process is completed, we will be ready to use this dataset for our experimentation and training. So now let's clone the repository from the GitHub using the git clone command. This repository contains all the code that we need to implement the YOLO v9 object detection model. So let's run this cell and clone the repository. As you can see, our repository has been downloaded, and now we have to need set the some configurations. So first of all, here I am setting two variables. Data directory holds the path where our dataset is stored, and the variable working directory which defines the path of our working directory, right? So because in a collab the working directory is content, and this is the path of our dataset. This path is actually the path of unzipped dataset, right? Make sure this thing. So we can just copy the path from there and paste in here, and the number of classes is the count of the classes, and classes is the name of the classes that is present in our data set. So let's run this both cell. Now here we are creating one YAML file that contain the file path for training, validation and testing data, as well as the number of classes and the name of the classes. We will create this YAML file inside the YOLOv9 directory, because we will perform all the experimentations and training within this directory. Okay, so let's first import the YAML file and the operating system, which is the import OS. Now create one dictionary. Train will keep the training path of the dataset, and it will the this is the path of this train folder, and the validation keep the path of the training dataset, validation dataset, and test will keep the path of the test dataset, and nc is the number of classes, which is the 10, and name is equal to classes, which is the name of all the classes that is present in our dataset. So let's run this and create one YAML file inside the YOLOv9 directory. After running this cell, we can see the one data.yml file has been created in our YOLOv9 format, and you can see this is the name of the classes, the count of the classes, and the path of our dataset. Right now, let's download the pre-trained weights of YOLOv9 model. Once the weights is downloaded, we will be able to fine-tune these weights for our custom dataset. This is always the best practice, to use the pre-trained weights and use these weights to fine-tune for our dataset. Right, as you can see, our weights downloaded in our working directory, and we can see right there, which is the YOLOv9 ep.pt. So right, so now move to the training process. So first of all, let's navigate into the YOLOv9 directory. By doing this, we can access all the code that is related to our project. So we can navigate into the YOLOv9 by just using the cd command, which is the change directory. You can see we are inside this YOLOv9 directory. So next, we are installing all the necessary packages using pip that is listed in a requirement.txt file, and -q stands for the quiet mode, which will hide all the installation process. Let's install the dependencies for our YOLOv9 model. And now our dependencies has been installed. Now it's time to train and fine-tune the YOLOv9 model for our custom dataset, and this command will initiate the training process for our YOLOv9 model. But before executing the cell, we need to modify two arguments. Right, the first argument is the hyphen data, and we need to pass the path of our data file that we have just created above, which is the data.yml, and we have created this file inside the YOLOv9 directory. Right, so navigate to the YOLOv9 and copy the path of this file, which is the data.yml, that which is contain all the path of our data set, number of classes and the count of the classes, and just paste right there. And the second argument, which is hyphen config. Okay, we need to make a little changes in the YOLOv9.yml file, because this original YOLOv9.yml file is configured for the Coco dataset, on which the YOLOv9 model has trained, and which contain the 80 classes. As our custom dataset, we have only 10 classes, so we need to adjust the number of classes parameter that is present in the YOLOv9 file, and pass the 10 instead of 80. So let's go to the models. Inside model, we have a detect folder. Inside the detect, you can see we have a YOLOv9.yml file. Just open this file, and you can see there is a nc parameter, which is the number of classes. And this, for the Coco dataset, it has 80, but as our custom dataset, we only have 10 classes, so we need to pass 10 here. So after mentioning this, we can save this file. As you can see, our file is saved and we are good to go with this YOLOv9.yaml file. So now copy the path of this file and just paste right there. So and hyphen hyphen HPY, which is contain the hyperparameter for our model, and we don't need to modify this, so we will leave this as is it, right? So let's train the model for 50 epochs, and here are some other parameter, which is the worker. We set 8 worker right there, number of batches, which is the 4 in our case, and the size of the image, which is 640 by 640, and the number of epochs we set it to the 50. And there is one more parameter, which is the hyphen hyphen device, which is 0. 0 means we are using the GPU for our training process. Now let's run the cell and fine tune the model on our custom dataset. We got the not found error of the weights. I think we are not put the right path of our, sorry, we have a pre-trained YOLOv9 model inside the content, not in a YOLOv9 directory, and you can see it. Just copy the path of this pre-trained weights and put right there. Now it will work. As you can see, our training has been started and it will take some time to train the model on our custom dataset. So once the training is completed, I will get right back. So guys, I have stopped the training process after the 10 epochs because the training of the model for the 50 epochs was taking so much time. So that's why I stopped it after 10 epochs, and you can train the model for 40 or 50 epochs, right? So let's navigate to that folder where our model has saved after 10 epochs. So this is the in a YOLOv9 directory. There is a folder called runs. Inside run there is a train folder. Inside train we have two experiment folder. The first experiment folder is created when we run the cell and we got the error, but the model that is saved after the 10 inputs will be in a experiment 2 folder. So open it, and there is a weights folder, and there is a best.pt file, which is our best model that is saved after the 10 epochs. Just copy the path of this model and use this model path for our detection. So let's make the inferences on the image. So for that we will be using detect.py file and pass the size of the image config 0.1, and the device is, again we are setting the 0, which means the GPU, and the weights. Now we have to pass the weight of that we have just copied. Right now we will be using the weights of the model that we have trained on our custom dataset. Just paste the path, and in a source argument we need to pass the image on which we want to make the inferences. So let's navigate to the data folder and copy one image and pass to the source argument. Just passed right there. Okay, now let's run the cell and display the detections. As you can see, our model has made the predictions on the image that we have just passed to the detect file. So it saved the result in a run. There is a detect folder. Inside the detect we have experiment folder. So let's navigate to that folder. Inside the run there is, now you can see it has created two folder and detect, and inside the detect we have a experiment folder. And just copy the path of this image and paste it here to display the image. So let's display it. As you can see, the model not making the perfect prediction because we have just trained the model for the 10 epochs. So let's try with another image. Just copy the path of this image and close all the tabs and paste the path of the image into the source folder again and run the cell and make the predictions again. Now again it saved the result in a detect, but now there is created one more folder called experiment 2. So let's navigate to that folder and copy the path of the image and put the path of the image right there to display the image. As you can see the model making the prediction, but there is some false in a prediction because we have just trained the model on a 10 epochs. So you can increase the number of size, and that model will be trained on more epochs and it will make the right predictions. So aim of our this video is just to show you how we can train it on our custom dataset, not to make the model more accurate, right? So as we have tested our model on images, now it's time to test the model for the video. So in a source file we have a source folder and I copy this hard hat.mp4 file, right? Let's copy the path of this video and passed in a source argument. After passing the path of the video in a source argument, now let's run and make the prediction on a video. As you can see, the result of the video predictions are stored in a detect folder. This time it stored the result in a experiment 3 folder. So let's navigate to the folder, download the file, right? After downloading, we can play it any media. So let's play it. As you can see how our model make inferences on a video as well, but there is a lot of wrong prediction that our model is making, and again this is because of we have trained the model only for 10 epoch. To make the accurate prediction, we have trained the model for more epochs. Okay guys, this is all for our today's video. I hope you enjoy this video. Please share, like and subscribe to my YouTube channel, and I will see you in the next video.